All right, welcome back everybody. Let's finish up our discussion of the repeated measures analysis of variance by doing one more summary table puzzle. In our last video, we completed a second example of a repeated measures analysis of variance, and we filled out this summary table right here. What I want you to do right now is imagine that you can't see that completed table. And let's focus on this table right here. And let's try to figure out how we would fill in all of those empty cells. It might help you to grab a formula sheet, because if you have a formula sheet in front of you, it's a little bit easier to remember how each of these cells interacts with the others. All right, let's remind ourselves of some key information. In this particular example, we were looking at 6 people making free throws, and we measured them across 4 different treatments, 4 different times. We measured them before any practice, immediately after practice, 1 day later, and then 1 week later. So we had 24 measurements overall. 6 times 4 would be 24 measurements overall. And there were only 6 people that we were measuring, so the small n equals 6. So that's some key information that'll be very helpful. You might recall that when we work on these puzzles, it's usually easiest to focus on degrees of freedom first. And that's because the formulas for degrees of freedom are usually very straightforward. Let's take a look and remind ourselves. For example, one thing that we need to compute is degrees of freedom total, and it's simply based on the total number of measurements minus 1. So let's fill that in. We just discussed that we have 24 measurements overall. 24 minus 1 would be 23 total degrees of freedom. Keep this in mind too. Degrees of freedom between treatments plus degrees of freedom within treatments must equal degrees of freedom total. So if degrees of freedom total equals 23 and degrees of freedom between treatments equals 3, then degrees of freedom within must equal 20. Let's remind ourselves of the formula for degrees of freedom within treatments just so we can check our work that way as well. That formula is right here, big N minus K. Let's go back and check to make sure it works that way. In that example, we measured people attempting to make free throws 4 different times, so K equals 4. If the formula for degrees of freedom within treatments is N minus K, 24 minus 4 does indeed equal 20. So it looks like we're on the right track. Let's focus on the between subjects source of variation next. And keep this in mind. All of the values that come from this source of variation and all of the values that come from this source of variation, when combined, need to equal this source of variation. In other words, degrees of freedom between subjects plus degrees of freedom error should equal degrees of freedom within treatments. Let's remind ourselves of those formulas. Degrees of freedom between subjects is very easy to compute. Small n minus 1, the number of people that we measured minus 1. In this example, we only measured 6 people. 6 minus 1 is 5. Remember, degrees of freedom between subjects plus degrees of freedom error must equal 20. 5 plus something must equal 20. So this must equal 15. Let's go back and look at the formula for degrees of freedom error and see if that number, 15, makes sense based on that formula. Here's the formula for degrees of freedom error. K minus 1 multiplied by N minus 1. K minus 1 would equal 3. N minus 1 would equal 5. 3 times 5 is 15, so we're still on the right track. Next, let's focus on sum of squares total. Keep this in mind. Sum of squares between treatments plus sum of squares within treatments should equal sum of squares total. So all we need to do is add this value and this value to find this value right here. 31.12 plus 72.5 equals 103.62. 103.62. All that we need to do right now is find sum of squares between subjects. And let me remind you, the source of variation between subjects and the source of variation error, they're both subcomponents of within treatments. So for example, degrees of freedom between subjects plus degrees of freedom error equals degrees of freedom within treatments. So this value right here, 29.63, plus this value right here should equal 72.5. So we should be able to take 72.5, subtract 29.63, and find out what this value is. So let's do that. 72.5 minus 29.63 equals 42.87. 42.87. Well, that's it. We completed the puzzle. If you check this right here, what we just did, with the summary table we completed previously, you'll see that they're the same. All right, my friends, I hope you enjoyed learning about repeated measures analysis of variance. I'll see you in the next video. In the meantime, be safe.